Thank you guys all for attending. This is an audacious presentation, so I hope you guys are shocked and critical, and I hope for good questions. This is work that I've done in conjunction with Eamon Engber, who you heard earlier, Allison Carroll from Humboldt State, and Steve Sillett, and I should also have Andrew Slack, who is also now with the Save the Redwood League on here as well. First, you know, fire in redwoods is kind of, we see signs of fire in the redwoods through these large cavities and charring on the boles. And most studies have indicated that fire was indeed pretty historically very frequent. And a lot of times that frequency is attributed to Native American burning practices. And while we know that climate is an important factor, understanding its variability is less well understood in its contribution to changes in fire frequency. We know that there's numerous recent lightning fires, as evidenced by some of the ones that Matt presented down in the Big Sur area, and one that's burning right now. Maybe we'll be studying that next. And so there's evidence for lightning fires. In fact, one of the field trips is going to be led by Hugh out to one of these recent lightning fires at the Canoe Fire, and I would encourage you guys, if you're not going on a field trip, to go to that one. And also Matt mentioned earlier about this potential for increased mortality from recent wildfires in combination with mortality related to sudden oak death that tends to increase the severity of these fires when in combination, that compounded effect. And there's a lot, and Eamon mentioned earlier that there's interest in using prescribed fire as a tool to reintroduce the ecological process that's related with fire and the benefits associated with it. And so, as I mentioned, there's been a number of fire history studies that have been conducted, and while the reports are wide-ranging, as short as every 6 years and as long as every 500 years, majority of the studies do indicate a very frequent fire return interval, time between fires. But only a few of those, in fact only 3 of the 14 published studies on redwood fire history have been cross-dated. And so there's not a really good estimate of the annual resolution of when these fires actually occurred, and true estimates of the year and time between fires. There's lots of missing rings. There's potential errors in those estimates. And it limits our ability to examine these fire-climate relationships at an annual resolution, especially across broad scales. And but one of the advantages is there's 14 studies that have been out there, and they're really well distributed throughout the Redwood Range. And so we might be able to use some of the existing knowledge to kind of tease really coarse and broad-scale relationships between fire history and climate. So what is the potential role of climate with redwood fire history? And clearly there's topographic and climatic factors that could be attributed to this variation, but they haven't been directly investigated. A lot of speculation. And 2 of the primary gradients that tend to be focused on are this west to east gradient that basically goes from coast to inland part of the range. And this reflects a change in temperature. You get warmer temperatures as you go from west to east. You get lower relative humidities, and you also leave the fog belt and into more less fog influence. Now, the other primary gradient is from north to south, where you get cooler, wetter conditions to the north and warmer and drier conditions to the south. And so what I wanted to ask is just kind of summarize, get familiar with the existing studies, see what the range of fire history out there is, and report on summarizing that to you guys here. But also looking at, can we find a signature of climate's influence topographic influence on fire history, and then also climate influences. They should be related, right? Some of the broad topographic gradients are linked with the climate gradients. And so what we did is, actually Andrew did, is compiled a database of past fire history studies. And again, there was 14 published studies, but there was a lot of sub-sites or sites within those studies that equated up to 67 sites where we have some estimate of redwood fire history. And what we focused on was the composite fire return interval, mostly because that was the shared metric of time between fires that we could analyze across this broad range of studies. And we used the mean composite fire return interval and the standard error associated with that mean. And so the topographic factors that we focused on were the latitudinal gradient that represents that north to south, and then that distance from coast. So how far away was that site from the coastline. And so you can see that this, through this map here represents the redwood range. So anywhere there's a color represents part of the Coast Redwood Range. But then the gradation is based on precipitation. So we can see the sites down closer, Big Sur, are 25 centimeters of mean annual precipitation, and then farther north is up to over 250 centimeters in mean annual precipitation. And so we garnered this data from the PRISM site website. This is modeling data that takes existing instrumental records and interpolates it across different topographical gradients. And there is some question of its accuracy along the coast, partly due to the influence of fog and also in mountain environments. But this is what we have. So this is, there's a lot of assumptions by using this data at all. And one of them is that this current climate reflects the past climate. We know that climate has changed. I've heard that's true. No. But less important to the actual amount of precipitation at any given point, I wanted to reflect the gradient across these two topographic or latitudinal and distance to the coast. And so we just basically used some simple regression analysis to see. Now this is just a test to see, do we see trends that seem to be meaningful? And so just from a summary of some of the data that we have, composite fire return interval was about, on average, between about 17.6 years between fires, with a pretty good range between 7 and 30. And I should make the distinction that composite is kind of, think of that as an area estimate of the fire regime, or fire return interval, where point is more tree specific. And as we would expect, the point centric would be a little higher, and so the mean was about 21 years between fires, with the range from 9.9 and 60.6. So when we looked at the different methodologies, and there's multiple methodologies used in redwood fire history construction, the best method, the standard, is cross-dating, where you actually can identify the years with some level of certainty. And so those estimates had slightly shorter fire return intervals at 14.3, and where ring counting, which is you're just counting the number of rings you can see visually, was a little bit longer, but not much, at 15.1 years. Basal sprouting, this is the aging of adjacent sprouts to to larger individuals that come after fire that we saw from some of Eamon's work. And these tend to be longer at 25.7. But I should mention that these different methods are not spatially equally distributed. And so the basal sprouting method was done from one study, from one site in Humboldt Redwood, so it's not broadly representative. When we look at time periods, just generally, we know that pre-settlement fire return intervals tend to be around every 12 years, where post-settlement was actually much more frequent, as frequent as every 5 years. And this was associated with, post-settlement activities, mining and logging and all that. Where modern fires, these are ones that are since 1940, were very frequent. In fact, they're almost, too frequent to really characterize as a return interval. When we looked at seasonality, a bulk of the times when fires occurred were in the dormant season. This is that time period of basically in the fall, most likely, extending into the winter. This is when the trees are not putting on radial growth. And then followed by late wood and then early wood with slightly less. But again, pretty wide ranging. And the reason this is important to highlight too is that, you know, a lot of these early season fires are often attributed more directly to Native American burning because there's just fewer ignitions. So what did we find? Well, surprisingly, we did not see a relationship with the distance to coast. This has been speculated to be a driver for a while, and there was no relationship with distance to coast and the mean fire return interval or the variation about that mean. So somewhat surprising, but this has been found in one other study by Brown and Baxter. We also looked at other factors that I didn't mention, like slope, aspect, elevation, and there was no clear trend either. I just didn't want to show you a bunch of non-relationships, if that's okay. But what we did see is that along the latitudinal gradient, there seemed to be some explanatory power of this gradient in relationship to fire return interval, where, as we would expect, that areas in more north latitude would have longer fire return intervals, where areas closer to like Big Sur would have much more frequent. And the range was about, you know, from 10 to 30 over this gradient. And kind of consistent with that trend was that the variation around each of those means was also positively correlated with that, with the fire return interval, meaning that sites more south were less variable than sites farther north. When we looked at actual measures of temperature of climate, and we looked at max temperature, we did not see a strong relationship with the fire return interval, but there was a slight but not significant negative relationship with the variation about the fire return interval mean. And so at higher temperatures, there tend to be lower fire return intervals. But again, that's not statistically significant. Oh, yeah, it is. So, so that latitudinal gradient seems to be explained mostly tightly with variation in precipitation. And so areas that receive much more precipitation are associated with longer fire return intervals, and areas that receive less precipitation have shorter fire return intervals. And the same is true with the standard error. So more variable to the north where it's wet, less variable to the south where it's warmer and drier. So we see some evidence suggesting variation in fire return intervals along topographic and climate gradients. Not shocking per se, but it hasn't actually been quantitatively assessed. But we did not see that clear signal of a west to east gradient. And again, as I mentioned, Brown and Baxter had also looked at this just at Jackson State Forest, so one area where they had a gradient going from coast to inland. And so we looked at a broader gradient, and we still didn't find any influence of distance to the coast. And so the decreased frequency and higher variability is associated with mean annual precipitation along this latitudinal gradient, and where higher amounts of precipitation in more northerly redwood stands may limit the fuel availability in one part, so lengthening the time between burns. And so frequency likely reflects this combined effect of climate and Native American burning. We can't use this data in a way to tease out the relative influence of climate and Native American burning practices, but it does hold potential for using this type of data to look at relative distance to known Native American village sites, and perhaps we can get a better sense of how that contributed to variations. There's still a lot of variation in the fire history to be explained. Increased likelihood of fire in redwoods prompts a need to better understand fire-climate relationships. The idea is that it's getting warmer and drier to the south, and the changes in the fog, the amount of fog on the coast could change the occurrence and frequency and size of fires in Redwood Range. And that's something I'm interested in looking at, seeing if we've seen, it seems like a number of fires have occurred over this year. Has it increased the area and size in redwood forests, in particular in the southern part of the range? So without, I'd have to say that I acknowledge the limitations, and there are many. Again, this is a cursory look. I was just exploratory data, kind of curiosity about seeing if we could see climate signals in very broad temporal and spatial variation in the Redwood Range. The variation in fire history methodologies is also a contributing factor. I mentioned that some studies looked at fire scars, basal sprouting. Some actually used tree cores to estimate fire return intervals. And there's really a limited amount of cross-dated studies that have used cross-dated data. And so the other thing that was hard to control for was the range of different studies. Some went back to 1300, some were less, went back to only the 1700s. And again, the metrics that we use to communicate fire return intervals, some studies publish mean fire return intervals, some studies use the composite. Very few studies look at both metrics, or at least report both metrics. And the few studies that reported both, there was a slight positive correlation between the two. Assumptions that current climate variation along Redwood Range reflects the past gradient. I think it's probably sound, but again, we don't have that data to actually assess that. But I am excited that this is work that was really focused on developing a fire history for Lower Prairie Creek and Redwood National Park, and we are working at trying to work with those samples and develop fire return interval measurements, and working with Allison Carroll, and she's had great success in developing chronology, more expanding our understanding of the chronology of redwoods with this potential of improving our ability to find, to cross-date in these fire scar samples. And Allison's also looking at the potential to use markers such as resin ducts and growth micro rings, is what they're called, really narrow growths that seem to be able to be detected higher up in the tree to some degree that reflect evidence of past fire. So higher up to the tree, you can cross-date much better, get more accuracy, and there might be some signature of fires, but we're still developing that. Examining the ability to, develop what I'd like to do is develop a fire history database where we have actual points of estimates of years based on either the cross-dated series or the ring count methods to see if we can better align some of these fire events and estimate the fire return intervals and link that to more annual resolution climate potentially. Thank you. And with that, I'd like to thank Redwood National Park, Save the Redwoods League that supplied funding to the park and to our lab. And then again, Andrew Slack did a lot of the heavy lifting here. And with that, if there's time.
I think we have time for one question. Anyone? Yeah, in the back.
Yeah, it seems to me that if fire sizes increase, then a particular location is going to experience more fires, even if fire frequency itself hasn't been increasing. Did you take that into account in any particular way?
For this analysis, not in particular, but I think it is, there's probably, I mean, we can look at least modern fires. Are you talking about historical fire?
I'm not being particular about that.
Yeah. I don't think we can, it's hard to say, I mean, we can get a sense for some of the sizes, but I don't think we have that information to understand. Yeah.